Now let's shift our focus to data types. In Python, every variable has a specific data type which tells Python what kind of data is being stored and how it can be used. So the main data types that you'll frequently use are integers, and integers are whole numbers, whereby these can be both positive and negative numbers. Then we also have the floating point numbers, also referred to as the floats, and these are numbers with decimal points. Then we also have the strings, which are sequence of characters like text, numbers, and symbols. We also have the Booleans, which are binary numbers that evaluate to true or false values. So let's have a practical example of data types. Let's look at the integers. So integers are also denoted with the int shorthand, and integers are used to represent whole numbers, which can be positive, negative, or zeros, and integers do not have any decimal component. So for example, let's work out with the positive integers. And with the positive integers, we are going to go ahead and declare a variable that is going to store the student mark, for example. So we define the name as student mark and then assign it a value as 80. That is a positive integer. And then for the negative integer, we can work with a variable that is going to store the temperature. So this is going to be temperature, and then the value is going to be maybe negative 100. And then we can also have 0. Maybe we can create a variable called sum that initially stores 0 as the current total sum. So with positive integers, you can always work with different variables. You can also have the total, and we assign it a value of 100. There could be also cases whereby you're working with the average, and then you define a variable that is going to store the average mark, maybe 70. So with integers, you can perform a wide range of arithmetic operations like addition, subtraction, multiplication, modulus, and many more. And we shall look into that while working with Python operators. So for now, we can just have a precise example of the arithmetic operations that can be done with the integers. For example, the addition. So now with the addition, we are going to update our positive integers in a way that we update the student mark to maybe student mark 1, and then a new variable called student mark 2, such that we can create a variable called result that is going to go ahead and store the value of student mark 1 and student mark 2 added together. So this is going to be student mark 1 plus student mark 2. And you can always go ahead and print the variable, whereby this is going to be a summation of student mark 1 and student mark 2. So that is 80. Also for student mark 2, we can update it to maybe 60. So the value for the variable result is expected to be 80 plus 60. So let's go ahead and run this up. So when I run the file, we are getting 140. And the same cuts across if we wanted to work with subtraction and all these other arithmetic operators. So this is going to be subtraction. So subtraction, for example, if you wanted to find the difference between the two marks, so define a variable difference, then we assign it the difference of student mark 1, then minus student mark 2. So with arithmetic operations, we always work with arithmetic operators, and the arithmetic operators are represented with symbols. For example, the one for addition is a plus, and then the one for subtraction is a minus. So you can go ahead and play around with all that. So I'll finalize the integers with the value for the difference. So we shall go ahead and print this variable. So we expect to see the value as 80 minus 60. So let's run this up. and the difference is 20. Now let's look at floating point numbers. Floating point numbers are also denoted as floats, and these floats always contain decimal places between the values. So for example, you can have a variable that is storing the student's average mark, whereby the value is going to have a decimal place. For example, this can be student average mark, and the value is going to be assigned to 79.1. So whenever you are creating a float number, you have to ensure that you give the value a decimal place, and decimal places can be one or more. We can also have a variable called total cost, and then we assign it to this value, then point maybe 00. And lastly, we can also have a variable that is storing the pi value. For example, we define a variable called pi and assign it a value of 3.14. So we can go ahead and work around with this and print the values for now. And this is through string formatting. So I'm just going to go ahead and print the student average mark. So the student average mark is printed as 79.1. So in Python, you also have the ability of customizing a float. For example, let's try to increase the student average mark to maybe 79.1543. And I'm going to go ahead and run this file. So you see that we are getting the value as 79.1543. So how about cases whereby you want to print this student average mark in a way that it's having one decimal place? So you always have the ability of formatting this variable. And now with the fact that we are working with the F string formatter, we can go ahead and format this variable such that we are printing only one decimal place. Now with the F string formatter, you always have the ability of formatting a float to different decimal places. So for example, we are going to go ahead and format the student average mark to one decimal place. So the syntax is that you access the variable, then you open colons, then you follow it up with a full stop or a dot, period, and you go ahead and pass in the total number of decimal places that you want. And for this case, it's one decimal place. Then you finalize it up with F. So here we are trying to tell the program that we want to convert the student average mark to one decimal place. So I'm going to go ahead and run the file. So you can pretty see that the student average mark has been formatted to one decimal place, and it is 79.2. Now let's look at strings. Strings are sequence of characters, and they can contain letters, numbers, symbols that are always enclosed within quotes. So for example, we can go ahead and define a variable called student name and assign it a value as John. Let's have another variable called the address. So this can be student address, and maybe he stays in Kampala. So then there would be cases whereby you are trying to work with a sentence, for example, maybe a welcome message that says welcome to the Python crash course, or welcome to this course, or a simple greeting. So this is going to be defined as welcome to this course, or welcome to this crash course. So this makes this value a string, and remember that the string can also take on numbers. For example, you can say welcome to this crash course 1, Or you can also go ahead and embed in some symbols. I'll go ahead and add an exclamation mark, something like this. So this makes the value to be a string. Now there are also cases whereby you went ahead and defined a variable called student age and assign it a value of maybe 20. Now, when you define such a variable called student age and assign it a value like 20, whereby the 20 is embedded within quotes, this makes the variable student age a string but not an integer, because with integers we do not enclose the value in quotes. So take note of this. So actually, let me just update this to age, because we know that generally you're going to define a variable age and assign it to 20. Now there are cases whereby you are just learning and maybe you forgot and embedded the age with the quotes. Then that means that it's a string and not an integer. And in addition, there are cases whereby you are trying to get maybe an input from a user and you are working with the input function. So by default, the input function is going to return a string, however much a user enters a value like 20 or 30. For example, let's just have a value called mark, and the mark is going to be prompting the user to enter their mark scored from the keyboard, and then we pass in the prompt string literal, enter mark scored. Then we go ahead and print the mark. So when I run the program, it prompts me to enter the mark scored, and if it is 89, and then we are having the value displayed as 89. Now at this point of time, you would be pretty sure that 89 is an integer. But with Python, you always have the ability of confirming the type by working with the type function so that you are sure of the variable that you are working with. So on line 45, if I go ahead and work with the type function and we pass in the mark, so the syntax of working with this function is that you define the function by accessing the type keyword and then the parentheses, and then the function takes in a parameter for the variable that we want to check the type. So I'm going to go ahead and rerun this. So enter mark scored, and this is 89. So the output we are getting is 89 and then class str. So str denotes that this is a string type. So whenever you work with the type function, it returns the data type to which the variable belongs. So let's also check for the data type of variable student mark 1 and student average mark. So this is going to be print. So access type, then student mark 1, then comma, type, then student average mark, then we run. Let's enter the value all through. So this is going to be 69. So you can see that student mark 1 is of type int, and then student average mark is of type float. So the type function returns the data type of the variable that you are working with. Now let's also look at the booleans. So boolean data types are binary numbers that evaluate to true or false. So by them being binary numbers, that means that if a boolean variable is true, then its value will be 1, and if the variable is false, then that means that the value is going to be 0. So generally, we work with booleans in a way that we are trying to question whether a variable is true or false, like we are trying to ask. So for example, if we had a student and we wanted to confirm whether a student is active or not. So basing on that, you go ahead and create a variable called isActive. So isActive, and the value of this variable isActive can either be true or false, meaning that a student can either be active or inactive, but not any other. So basing on that, we can pass in either true or false. So for now, we are going to set true. Then you can also have a variable called isCompleted that confirms whether a particular task has been completed. So the way we define the Boolean variable, say is completed, and then by default the task is going to be pending, meaning that it hasn't yet been completed, so that means that it's going to be false. And also there will be cases whereby you want to define a variable that is going to check if the page is loading or not. You can create a variable called isLoading, and then by default it will be false, meaning that the page is not loading. So you can go ahead and print the variables like isActive and try to run. Okay, it's still bringing up this. Anyway, let me just enter 79. So you can see that when I print isActive, it gives me the value that is true. And we can also check for the type of this variable by working with the type function and then passing in the variable, which is isActive. So the type of the isActive variable is a bool, meaning that it is a Boolean type. It can either evaluate to true or false.